A ball of mass small m is suspended from a bar of mass capital M with a light inextensible cord. So this is an ideal cord, this cord, and it is connecting a bar of mass capital M with a hanging ball of small mass m. Initially, the bar can slide on a frictionless slope of inclination theta. This bar can slide like this. Inclination angle is theta. Initially the bar is held motionless so that the ball also stays motionless, and then we have to find the acceleration of the bar and the ball relative to the ground in the ground frame, and we have to find these accelerations immediately after the bar is released. So the orientation will not change immediately after, so only the forces will act. Initial velocities can be taken as 0. Acceleration due to gravity is g. So if we import this diagram and draw the forces acting on the bar and the ball is connected to the bar with the ideal string, so a tension will act like this, and this tension will act in the downward direction on the bar. Weight will act mg, small mg on the ball, and on the bar there will be mg sin theta plus a component of this tension also. So the component of this tension will be t sin theta, and similarly in the perpendicular direction the forces of acting on capital M will be a component of its weight mg, that will be mg cos theta, and a component of the tension that will also be t cos theta. A normal reaction will act like this. And if we assume that the initial accelerations of the two blocks are, let us say for small m it is a1, the a1 will be vertically downwards since the forces are in the vertical direction and the initial velocity is 0. For the bar it will slide along the inclined plane, so let us take its acceleration as a2. So we will get two equations from the bar and one equation from the hanging ball. Also a1 we can write, let us use black color, a1 will be equal to a2 sin theta, because we know that for a inextensible string the accelerations along the length of the two end points are equal. So if this is a prime and this is a double prime, then a prime is always equal to a double prime. So a2, the component of a2 along the length of the string, this component will be a2 sin theta. So this a2 sin theta should be equal to a1. So that is why we have got this equation. So let us call this equation as 1. Let us remove it here. Now for the hanging ball we can write mg minus t equal to mass into a1, second equation. For the bar we can write, if we take sin theta as common, we can write mg plus t into sin theta. This should be mass of the bar into acceleration of the bar. This will be third equation. And there will be a fourth equation also, which will not be very useful here. The fourth equation can be written for the bar perpendicular to the bar. So n should be equal to, if we take cos theta common, then n should be equal to mg plus t, and cos theta will be common. So this is the fourth equation. So basically we have to find a1 and a2 here, and this fourth equation is involving another unknown n. So this equation will not be handy here. So we are going to basically solve equations 1, 2 and 3. So from equation number 2 we will write as it is. So equation number 2 is mg minus t equal to mass into acceleration 1. And for the third equation we will divide by sine theta on both sides. So third equation can be written in this way: mg plus t should be equal to m by sine theta. Sine theta we have taken in the denominator on the right hand side, and in place of a2 we can write a1 upon sine theta from equation 1. From this equation, a2 can be written as a1 by sine theta. So if I add these two equations, t will get cancelled, so m plus small m into g, t gets cancelled, and a1 we can take as common, so small m plus m by sine square theta. And if I take LCM on the right hand side, I get a1 into capital M plus small m into sine square theta and divided by sine square theta, and this value will be equal to m plus m into g. And from here we can directly write the value of a1, the acceleration of the hanging ball just after release. So this will be m plus small m into g into sine square theta, we can cross multiply, and divided by capital M plus small m into sine square theta. So this will be the acceleration of the hanging ball. Also from equation 1, a2 is a1 divided by sine theta. From this equation also a2 can be written as a1 by sine theta. So we have to just divide by sine theta in the above expression. So we will get m plus small m into g, 1 sine theta will get cancelled, and divided by capital M plus small m into sine square theta. So they are the answers, required answers. So that is it. I hope you get it.